All right, we are live. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. Good to see all of you guys. Let's see, let me just scroll through chat really quickly. 3D Code Warrior, good to see you. Apotham, good to see you as well. Spiro, welcome. Third or fourth, you guess. Yep, fair enough, though. Appreciate you being here. Enigma Dev over on the YouTube side, good to see you. Deepa as well, hello. Hope all of you guys are doing well tonight. We're going to pick up where we left off on the last stream. Starting to close up this loop on this SSBO refactor, I think / hope. So we're going to continue that tonight, see how far we get. Before we do that, though, I just want to take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Gerbolis Inc. and Matt Osgard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen scrolling by. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated, and it helps me cover the costs of hosting this project and the channel, right? So things like software licenses, hosting fees, things of that nature. So I really appreciate it. Thank you so much for that support. And of course, I would like to extend a big thank you to all of you, the viewers who are joining me live, either on the YouTube side or the Twitch side. We do simulcast both. I've got the chats up here on the screen on different monitors. That's kind of why I'm motioning to it. But yeah, without you guys, of course, you know, this channel would not exist. So I appreciate each and every one of you guys being here and supporting me. I really appreciate it. Thank you for being here. All right. So, in terms of where we left off, I did get a chance here in the last half an hour or so to kind of push things forward a little bit further. And it just kind of was going through the code base and just kind of resolving the errors as they came up from all the refactoring stuff that we've done. And I believe we briefly looked at Illumina Renderer last night. I don't exactly remember where we had left off, but, you know, we had, I think, like 170 something errors in there or something like that. And we're down to 31, and a lot of those I think are fallout, you know, from some of the other things that we've done, and should be relatively quick to fix. So with that in mind, we're just basically kind of going through and resolving them one at a time. And yeah, that's essentially what we're going to do. So the first thing that we're looking at here is in the world debug pass. So one thing I should mention is that I did go ahead and switch up some of the shader configs offline, and I've also refactored some of the shader code to sort of match the new way of doing things using the binding sets. So a lot of that stuff has been done offline. You know, you guys have kind of already seen me do it, so I don't feel too bad about doing that off camera. LSR, good to see you. Welcome. Hope you're doing well. All right, so looks like a lot of the issues that we've got left are sort of just kind of converting the old way of doing things to the new way of doing things within the Illumina renderer. So this is the world debug pass. It's got some issues, and then the editor gizmo has got some of the same issues, so we'll have to resolve that. The standard UI, I think, has already been worked out, so I think that is good to go. I think most of the rest of the issues are actually in this section of the file, and then we can kind of move on after this and see where some of the other issues are. So let's see, with that in mind, so this is our per frame data, and this is for the world debug pass. So we don't have per frame data anymore. What we have is up here at the top, we have this world debug global UBO, which the shader has been adjusted to match. And then we also have the immediate data here. So those are just structures that we use to sort of apply those things. So we're making a little bit of an assumption here in terms of the world debug data, at least, that we are only using this shader once. I'm thinking that we may eventually at some point need to adjust that. But for right now, we're just going to go ahead and make the assumption that we're only using it once. Okay, so per frame data, this is going to wind up being global UBO data. And we want a world debug global UBO. We'll just call this global UBO. Sure, global UBO data. And we'll just set the view to render data, world debug data view. And then we'll do projection kind of the same way. So it'll be render data, world debug data, projection. And so that's already kind of got the render info that we already built earlier. We're able to just kind of use that as is, at least for now. So there's that. And then as far as passing that over to, as far as actually passing that over to the shader, all we will need to do after this use, of course, here is to go ahead and set that. So we have kshader, and then we'll do set binding data. So the shader is going to be the renderer world debug pass debug shader. The binding set is going to be binding set 0. The instance ID we will have gotten before, so that's also going to be renderer rather. World debug pass, and then set 0 instance ID. That was another thing I sort of did offline, but you guys have already kind of seen me walk through that process, so I think I'm fine leaving that out. And then the binding index for UBOs is usually 0. The offset is 0. And then, of course, the data is going to be the address of the global, what did we call that? Global UBO data. Global UBO data. And then, of course, the size of that is going to be the size of this guy here. So we'll just do a size of, slam that in there. And that is all that goes into setting that data in the UBO. We also need to do one other step, which is kshader apply binding set, right? So after we've set everything in that binding set, we need to apply it. That was one thing that I had missed. We should probably quickly go over what that actually does. But let me just plug this in real quick here. Whoops, we should go renderer world debug pass debug shader, binding set 0, and then instance ID again is going to be renderer world debug pass, and then set 0 instance ID. So this essentially sets the data, and then this makes sure that the descriptors are up to date. So that replaces all of this per frame stuff that we're doing here. It winds up being about the same, but where it simplifies a lot is actually all of this stuff here, because there's a lot of this stuff that's now obsolete. So let me see here. What were we doing here? Because I don't even know if we actually are going to need this block. Let me bat this off to the side here. So we didn't have instance level uniforms to be set. And I don't think we actually have anything except immediates, right? So we have the model matrix and the color to be set. And that's just immediates, right? And then we actually perform the draws down here. So let's see. Okay, so we also had this concept of max scene debug draws, where we had to sort of go through and acquire resources for every single draw. We don't actually have that anymore, so that clause can actually go away. And all we actually need to do now, we can actually just delete that comment. That doesn't really apply anymore. And we just do a world debug immediate data. We'll just call this, I guess we can call it immediate data. And in there, we set the model to geo model, and we set the color to geo color, right? And then from there, we can just do K shader set immediate data. Again, we're going to want renderer world debug pass debug shader. The data is going to be the address of immediate data, and the size is going to be size of world debug immediate data, right? And we don't actually have to apply this one. Immediates are just immediate, right? So that replaces all of this, rather, right? And so this is just missing the renderer state being passed to it. So we can go ahead and put that in here, and then put that there. And that pretty much fixes it, right? That's up to date. So it's essentially just replacing sort of the old way of doing things with all the uniforms and all that stuff. We don't do that anymore. We just have UBOs going forward. So I think I've got all of that right. We'll see, obviously, when we go to run it. What editor am I using? I'm using NeoVim. First time chatter, by the way, welcome. So that there is a link to a article on my website that goes over my NeoVim configuration, what plugins I'm using, and then also it contains a link to a GitHub that actually has the .dot file in it if you're interested in that. Singy, good to see you over on the YouTube side. How are you doing? Hope everything is well. All right, so that's the world debug pass, and I think I'm actually thinking the editor gizmo is going to wind up being pretty similar. So the editor gizmo, I think the only real difference is going to be in the immediate data, if I remember correctly, because I think that only uses the model matrix. It does not actually use a model matrix and a color, because the color is applied from the vertex data. So we are going to be able to simplify this a little bit. So I think what I'm going to do is I'm actually going to come up here and let's see. We have the world debug global UBO. We need to copy both of these because we need versions of these for the color shader, right? So we're going to say color, I guess we'll do color 3D global UBO, I guess. And then we'll do color 3D immediate data. Now, this is the shader that we're going to wind up, I think, using in multiple parts of the system. So I think at some point, we're probably going to have to add some instances to the global UBO. But for now, I think this is fine. So the only difference, like I said, is we don't pass color here. So we have that, right? So we can just switch that in our code below. So what I'm going to do is I'm actually just going to copy this and come down here to where we're actually doing the per frame data sort of the old way. And I'm going to just do the color 3D global UBO. And that is going to be pretty much the exact same, except instead of world debug data, it's going to be editor gizmo data. And then this is going to be, let's see, change. This is going to be editor gizmo pass color shader, right? So we want to do that in a couple locations here. And then we have the editor gizmo pass here and there. And then we want to do this. Change that structure there, right? So that's the global UBO data. I think we got everything there. Okay, yeah. So this can go away. Don't need that anymore. And then, let's see. Wait a minute, are we doing this? I guess technically because we can use the color shader for multiple things, we do need to set the global UBO data, even though we're only using it for this once. Okay, so the other thing we need to do is we need to grab the logic here for the immediate data, right? So we'll go ahead and do that. And that is going to live here. Right, so this is going to be, again, this is going to be color 3D, immediate data, and then we'll go here to the end as well and make that same substitution. And then the model, let's see, that's just here, right? So that's just model. So we'll just use that. And then we don't actually have color for this guy, so we can get rid of that. Right, and then this is going to be editor gizmo pass, color shader, and that's all that's needed for the immediate data, at least for now. I'm gonna keep this on one line, and then we can delete that, and then we need to add just the renderer state here. Renderer states. Okay, and that's that one updated. So relatively straightforward stuff, I feel like. Awesome, thank you. I'm going through my operating systems class right now and using the Helix editor, which is also Vim-like but way more user-friendly. I do want to go back and try NeoVim soon. Does NeoVim have an interactive debugger like an IDE? There is a plugin that you can use for that called NVim DAP. I've used it here on stream. At least when I tried it, I was not a huge fan because there were some issues with debugging multi-threaded apps. I don't know that that's still an issue or not. It may not be. It worked pretty well until I actually hit that point. So that is one you could certainly look at. It's just nvim/DAP, right? That would be probably... I think there's another one too. I can't remember the name of it. But what I usually do now... in terms of a debugger is I just use this guy, right? Which I don't use this for editing, but the debugger is, you know, it's one of the better ones out there. It's still not good. It's not what I would call good, but it is one of the better ones. Printf is all you need. Yeah, I do a lot of printf debugging, essentially. Yep. I do have a log file that I write to a lot, so that has helped me on more than one occasion. We also have a console within, you know, like an interactive console within the game engine too that I use for some stuff. So it depends on what I'm debugging. Thank you for the follow, by the way. I do appreciate that. Okay. So, let's see. All right. So we have scene pass, and then this is prepare per frame stuff for the material. Didn't we already set this stuff up in the material renderer? Did we? Is actually the question. I don't think we did. Here's all of our texture stuff. I don't think we did. This is all setting the binding textures. I don't see the UBO in here, though. Okay, so we're going to have to do that. So a lot of this logic is going to wind up over here, I think. We had this concept of like setting the renderer mode, setting the shadow bias, and all that stuff. Have we... State settings render mode. So that might wind up being a thing. Let's see, scene pass. I feel like that should probably be set elsewhere besides the scene pass, but we'll do it here for now, and then if we need to move it, we can. So global material renderer settings. So I guess what we'll do is do renderer material renderer settings, and then here's all of that stuff. So this settings is essentially what's going to replace all of this UBO stuff that we're doing here, right? So all the let's see, the view positions, the delta time, game time, the views, all of that stuff, right? That's all going to be set here. I feel like I'm kind of feeling like this is not the place to do it though, because this is an individual scene pass, right? Which is not on a global level. So I feel like this doesn't even necessarily belong here. Let me think about this for a second. So where are we? So we do render frame. Yeah, and then the only place we actually use that is scene pass. So we probably ought to, before we even do any of this begin frame stuff, we probably ought to set some of these settings here. So let's do the global material renderer settings here. So we'll do, I guess we'll do renderer, material renderer settings, and then game time equals game time. Right? You can do that. And honestly, I might just eliminate these local variables too and just kind of feed it directly. Let's actually just take a convenience pointer to this. So we're going to do k material settings UBO. So let's do k material settings UBO. And we're going to just call it settings. And that's going to be the address of this. Right? And then all we have to do is that every single time, right? So we can do, settings, delta time. In fact, you know what? I am actually going to remove these two because I want to see where they're used, because we probably shouldn't be using them within here, right? So get rid of those. And we'll do settings, render mode. Actually, where were we getting that? So I might actually need to split. Oops. Other way. So when we're doing the scene pass, we do get some of these settings passed through. So I guess we can actually get most of that from whatever's passed when we call this, right? So render mode is here. So we can do that one. Settings, render mode equals render data for data render mode. That one does make sense. Settings, views. Do we actually have? Oh, I wonder if we're going to actually have to. I wonder if we're going to have to iterate our render data structure to actually get that. That would be absolute poop. Let's index this 0 for the time being. So we're going to say that is equal to render data Forward data. Do we have? Yeah, we just have one. So I think we had said for the views that the first one was always going to be sort of the standard pass view, right? And then every other one was going to be the reflection and refraction views for each individual water plane, right? That's the whole reason we have an array of those things. So the first one is always going to be that, but then we have the water planes to consider. So we'll do I is less than render data, forward data, water plane count, right? And then plus plus I. And then from there, it's going to be settings views, and then I plus 1, right? Because the first index is always taken by the standard pass. And then we'll do, so for each of these water planes, we'll do, I forget, do we do the refraction first or the reflection? Pretty sure we do refract first. Yeah, we do refract first. And then reflect. Okay, so we'll do render data, forward data, water planes, sub I. And then we'll do refraction pass, view matrix, right? And then we'll do the same thing, except it'll be I plus 2. Water plane sub I, reflection pass, right? So reflection pass view matrix. And then instead of incrementing I once here, we're going to have to actually do I plus equals 2, right? To move us forward 2 slots each time. So that's going to fill out our views. And then let's see what else is in here. Cascade splits. Didn't we have that? Forward data, cascade splits. We do have it. Okay. Wait a minute. Oh, I've got to loop through this, don't I? Wait, what? All right. Well, that's, okay. Why did we do it this way? Here, and then, so we basically just have to translate, all right, let's do this. So we're going to do a K, let's do a K copy type C array, right? The dest is going to be settings, cascade splits elements. The source is going to be this. Oops, crap. There we go. The type is going to be F32, and then the count is going to be 4. Right? So that will take care of that. And then settings, let's see, what's next? Projections. We can have 4 projection matrices, right? So the purpose of this is if we have additional things that we need to render the scene to that have like a different projection matrix, like if it's to a square texture or something, for like, let's say we were going to render a security camera or something like that to a texture, that's when we'd want to use this. But for now, we only have one of those, so we're just going to set one, and that's going to be settings, and that's going to be, whoops, not settings. That's going to be render data, forward data, projection. And I'm going to do a fix me in here for later. Allow multiple projection matrices for screen sized renders of the scene. Let's see. Catch up on some chats here. Is what you're doing open source? Yes, it is. Let's see. That's hilarious. I also just switched over to code for debugging. Oh yeah. So putting VS in front of that is this is a family friendly stream, so I have to censor anytime I say, VS. Can't have that, can't say that here. Let's see. So the open source question. All right. So let me do. So I showed you this website before. I'll drop a link here in chat. So this is sort of the main website for the project. And if we scroll down here to contribute on GitHub, the engine itself is here. It is free and open source. It is Apache 2.0 licensed, which means that it can be used either for a personal or commercial project. Does not matter. All that I ask is that if you use it, you say you used it. That's literally it. There'll never be any sort of paywalls behind this or licensing fees or royalties or any of that stuff for the engine. So yes, it is free and open source. However, it is not production ready yet, so I don't recommend using it for much more than a reference on how to do stuff at the moment. Let's see. Dingus Dev, thank you for the lurk. Appreciate that. Let's see. How hard is it to achieve building an engine with the looks of Lies of P done in Unreal Engine, or generic renderer can do the work while the artist does the magic? So, hang on a second. Let me just pull up. So you're basically talking about this, like this kind of a look. I mean, it depends on how close you want to get to this look, right? Like there are things that are more complicated than others. There are aspects of this that are relatively straightforward, like setting up a PBR renderer. That is not the most difficult thing in the world. But when you start talking about things like global illumination, that gets not complicated, but it is a little bit more complex than just your standard lighting system. So it really depends on what features you want to support. Do you want to have, order independent transparency and stuff like that, like what Unreal has? It depends on what you're trying to accomplish. So, artists can work some magic in BSing things, right? But at the end of the day, your renderer needs to be able to handle some of that stuff in real time as well. So it's kind of an open-ended thing. Unfortunately, it's not really a one-size-fits-all answer. You use NeoVim, but it's awful. Why is it awful? What would be a splash screen for Kohi? I haven't thought about that. I actually, at some point, am going to create one. When you launch the application, it'll have a little splash screen before it actually brings you into the game. I haven't really thought about it, to be completely honest. It'll probably have the Kohi logo on it, obviously. Probably just a black screen with the Kohi logo on it, I would imagine. Yeah. You use NeoVim every single day? Yeah. Oh, the you're talking about the code completion is terrible, or I don't know. I've had pretty good luck with it. It works pretty well for most things that I do here. Okay. So let's see. We had a couple other things here. So settings, directional light spaces. So that's going to be render data, forward data, directional light spaces. We also have that, but that is also going to have to be an array copy. So k copy type C array, and then that's going to be target is going to be that. Source is going to be this. Oops. And then the type is mat4, and the count is 4. So we've got that. Settings. See what else do we have in here. So we have the shadow settings. That's kind of important, right? So shadow bias is going to be render data, forward data, shadow bias. Settings, shadow distance is going to be render data, forward data. Shoot, do we not have that in here? How did we not get... Oh, because it used to be part of the directional light. I wonder if that's... That is still here. I might want to think about changing that at some point, but for now I'll use the structure as it is. So the next thing is going to be the shadow fade distance, which is going to be render data, forward data, directional light, shadow fade distance, right? It used to be tied to the directional light. It's not anymore, so I'm going to have to fix that. And then the split multiplier for the cascaded shadow maps is going to be also under the directional light, right? And then we have settings. Settings. Let's see, use PCF is the next one. So that's going to be render data, forward data. Actually, don't we have, I think we actually get that as part of the state, don't we? Didn't we get, where did we have that? Another renderer front end has it. I mean, I suppose I could get it this way. That just seems... K-material renderer. It does have it in states. Oh, the state settings use PCF is already set in the update. Okay, so I don't need to actually do that one. Is there anything else under here that need to be set? Oh, view positions. Okay, that's going to wind up being... That needs to be integrated into this loop here. So settings, view positions, sub-0 is render data, forward data, standard pass, view position. Does that not exist? To vec3. Oh. Forgot about that. All right. So we'll have to do vec4 from vec3. And in here, we're just going to pass that as the XYZ, and then we'll use 1.0f as the W, right? And then here, inside the loop, let me bat this off to the side again. So inside the loop, we're going to do So I think, let me think, view positions. We do need a view position for reflection and refraction as well. Yeah, okay. So we have to do this twice just like we did here. So this is going to be I plus 1. And then that's going to be the refraction pass. Oops, yeah. Water planes. Sub I. Refraction pass. View position. And then we want the same thing, just I plus 2. And we want the reflection pass. Okay, so that takes care of view positions, and I think that's all the settings we need. So the settings will be here, and then all we should actually have to do within scene pass, or actually even before scene pass, since these settings are essentially the K-material shaders global settings, we just need to make sure that those get set. So let me close this second buffer out here for a second, and whoops, and we'll scroll down here to let's see, past the shadow pass. The forward pass is what we want. Let's see. So this is going through. Do we actually have any calls to the global? So apply globals. We do. Apply the material settings. Okay, so this will actually take care of all of the stuff that we've done previously. So actually, I think we can actually literally get rid of all of that. We do need the irradiance maps to be set, but I think all the rest of it could go. Oh, not all of it. We need that line too. Not 100% loving the way that that's coming together. We may have to do a little bit of extra cleanup on that so we don't have as much back and forth. Thank you for the lurk. Appreciate that. Wesley, first time chat. Welcome, by the way. Use NeoVim every day. It's the best editor. Yeah, I agree. I like it a lot more than anything else I've ever used, for sure. It does take time to kind of get good with it, or at least decent with it. I am by no stretch of the imagination a Vim expert of any kind, but I'm good enough with it now that I'm actually faster than using any other editor. If I have to use another editor, it actually slows me down at this point. Okay, so now we have scene pass, which is bleating, because we are passing in delta time and game time, which I'm pretty sure now are not going to be used. Yeah, I don't think so. So let's do scene pass, right? Actually, we'll do that. And so we'll go to the definition. Did we not forward declare that? Oh, I guess we didn't. Okay. So we don't need delta time and game time anymore. I think we got one more. Yep. Okay. Render mode I also question if we need. So we did have a to-do here, like evaluate all these and see if we're actually using them. Render mode. I suppose what we probably ought to do is just kind of look through here and see if like deleting things gives me any errors, right? So let's, I think this is literally just going to be we want to delete that and delete that, right? Okay, clipping plane, I think also, I feel like a lot of these are going to wind up going, actually. I think all 4 of these can go. Let's see. Draw geolist clipping plane. Does this actually need the clipping plane? Yes, it does. Okay, so we can't eliminate the clipping plane. But we can eliminate these, I'm pretty sure. So it's going to be these 3. One more. Right? Already a lot easier to parse, right? Point light counts. Does that... let's see. I don't think we actually need that or the point lights to be passed through. I think we can actually get rid of that as well. Yeah, so that and the point lights can go. Oops, these 2. All right. I don't even know if we need like projection and view index. View count. Oh, we do need view count and the views. Okay. Do we need the projection? We do need that. Okay. We need those for the skybox, unfortunately. So that's fine. We do need these. Those are our render targets. Clipping plane we decided we did need. A radiance cube map texture count. Yep, we do need that. And obviously the textures array. Skybox data we need. Pass data we definitely need. Direction light. I don't think we need that either. I think we can actually get rid of that. Yeah. Okay. And then obviously the water planes and stuff we'll need. So I'm a lot happier with that parameter list, I'll tell you. So I'm going to get rid of that fix me. We're going to consider that fixed for now. I do eventually want to clean this up a little bit, but I think that's a good enough place to be for now. All right. Any UDP, TCP library, or API recommendation for making an online cards game? To be completely honest, no. I haven't written that stuff in a long time, and when I did, I had to roll it from scratch last time I wrote it. So, yeah, I don't have a recommendation there, unfortunately. Could never get into Vim back in the day, but now I only want to use NeoVim. Yeah, that's fair enough, right? What language? I'm using C. Oh, wait. That was a question to the other guy. Okay, I gotcha. What in the world do you need UDP for a card game? Yeah, I would question that too. Wayland when? Do you mean Wayland platform support? It's probably going to be a while, actually. X Wayland is working pretty well. And like I'm actually running on Wayland right now, right, via X Wayland. But I've read and heard about some goofy stuff with swap chains. And if you basically want to, if you don't want to use a library for it, you basically have to write a swap chain for Wayland from scratch, which I don't know that I necessarily want to do at the moment. Planning on going with C or Odin since I'm experienced with those. UDP for viewing what the player is moving in real time. Interesting. Okay. So when you say moving in real time, like what kind of movement do you need to track for a card game? I'm a little curious about that, I guess. Let's see. Vulkan backend, we have another unused variable, 2901. Lumina renderer, unused variable cascade, 601. Okay. So 601. I guess we don't need this guy. Sure, that's fine. Resources scene H not found.
You dingus.
Really? I thought we had gotten rid of all that. Thank you for the follow, by the way. Appreciate that. Welcome. Yeah, we definitely don't need that anymore. Zone system is also has that. I guess I just forgot to remove the includes because I know it's not referencing that code anymore. Okay, we built. So that's pretty cool. So what I'm actually going to do, well, I guess we could try running it. I can almost guarantee it's going to crash. Because I'm sure with all of this stuff that we've changed around, I'm sure I've forgotten to do something. But let's go ahead and run it and see what we get. Bonk. Immediate. Knew it. Okay, this is during buffer creation. Oh, that's interesting. Okay, so what did we... Object type, we're treating that as a string. That doesn't seem right. So, what was that? Okay. That was a new, so... This was a new function that I added. So up till now, we sort of had this Vulkan set debug object name, right? And I added to that a indexed version of that, so that we didn't have to sort of build the string in our code base all over the place when we want to have an index of something. But for some reason, I'm passing object type here. And that really should be object name. Right, so it should be object name underscore index. Not really sure why I did that. Dingus-oriented programming, I guess. Let's relaunch. Okay, now this does not surprise me a bit. Okay, so mapping memory without property host visible bit. So that's probably going to be a storage buffer that I didn't set up the mapping correctly for. Let's see, initialize. Oh, that's an index buffer. Render buffer flag none. How did we get there? Wait. Huh? Didn't I just say that we had nothing set? Yeah, there's no flag set. Internal buffer flags. How did we get... So the flags here is 1. Huh? How did we... Did we add a flag to this somewhere? Help me understand. So flags is 1 here. Which that is automap memory. Yeah, no wonder it's complaining about that. We shouldn't be doing that for an index buffer. How did we get that set to 1, though, is what I'm not understanding. Yeah, it's there. But when we call this, it's 0. Are my parameters in the wrong order or something? Yep. Oh, what a dingus. Okay. Cool. So let's see, that was in... Got some more dingus-oriented programming here going on. Line 1000. So when we do our render buffer creates, if we look at the parameter list, it is, at the very end, it is flags and then buffer. But we are passing the buffer, then the flags. So that should be that. Okay. So this is create a global material storage buffer. Okay, that's good. Let's see. Looks like some serialization issues going on here. So we're going to actually have to figure out where that is coming from. So what I'm going to do is just grab this. Oops. And we're just going to... failed. Here we go. I'm going to stick a breakpoint right there. Let's see. For example, if a player picks 3 cards and moves the cursor stuff, but well, maybe I should write out that part. Yeah. Make things a lot easier, right? Just use TCP stuff. Yeah, I would go with the simpler solution first and then expand on that if you wanted to. Are you using AMD's VMA library for your Vulkan memory? Nope. We wrote our own allocator for that, which is not hugely robust at the moment, but it just kind of hooks into our system allocator. but we have the ability to enhance that to make it better. Let's see. How do you even know creating such a thing without already creating one before? And how do you even know how to create one? That's a loaded question, I guess. So I assume you're talking about the engine with that question. So I have created these things before. So experience kind of guides me a little bit there. Or I've created enough things that are similar in concept, or have learned enough things conceptually to put ideas together to actually build something, if that makes sense. Mostly comes down to experience. All right. So, that would be why. So we're trying to add a kname as string, but we don't actually have a kname being passed. Like 0 is an invalid kname, right? So what are we trying to serialize? That's the binding set name. And that is in the material standard shader, right? So let's see, the binding set name. Binding set 0. Yeah, sure enough, we didn't set a name. We have the binding count, the bindings array, the max instant count, but we didn't actually set a name. Which I guess we don't need one, but it's good to have, for debug purposes, right? So let's just go ahead and do that. Since we're creating this in code, which is not necessarily the normal way that we do it, we'll go ahead and do that. But also, I probably am going to fix the serializer to say, hey, if we don't have a name, don't bother trying to serialize it. That way we don't get those warnings. So I guess let's take a look at K material renderer. And that's going to be around line 147. So let's see. Binding counts. Okay, so let's do set 0 name is equal to kname creates. And we're just going to put in here material standard shader global binding set, right? Doesn't really matter what the name is. We can call it anything. Mostly where this is going to show up is going to be in our debugging, right? So we know what the heck it is. So we have set 0 name there, and then we're also going to need a name for set 1. So this one is just going to be set 1 name, and we're going to have material standard shader. What did we actually call this? I think we were going to call it like material, or maybe base material binding set, right? And we're going to do the same thing for this guy. And I'm actually going to come down here really quickly and just paste set 1 and then go back to set 0 in a second. Just because that's already set, right? So this is going to be this is the skin shader, right? So which I see actually that, and there's some copy pasta issues. Okay. Okay, so we've got that, and then this just needs to be set 0, and this is going to be skinned shader base material binding set. This is going to be global binding set, right? So we'll grab that, and the last one is going to be the water shader, which we are going to be combining these things, but I want to at least get them right for now. So we can do material water shader, and then go down to set 1 for this guy right here. And we're going to do material I think we said base material. Binding set. Right. And then, let's see, where exactly was that? We don't have the debugger up anymore. All right, let's just go through it again. Actually, I can pull this up here. Did I rebuild? I forget. I think I did. Okay. All right, let's run it again. Try and eliminate as much stupid stuff as we can, right? So this is still the standard material shader. So what is it complaining about now? Name. Okay, so add. So this is the individual bindings. Did we not have a name for a particular binding? Binding 8 does not have a name. Oh, I guess a lot of them don't have names, right? Wait a minute, though. Well, that's the water shader. Maybe that one has names and some of the other ones don't. No, all of these ones do. Unless I'm missing something. Which I very well might be. But I think this is a good opportunity. Like, we don't have to necessarily do this, right? So let's see. That's going to be the KS shader serializer at line 150. Right. So what we're going to do is if binding name, because that's not really a required property, right? Then we'll go ahead and do that. Okay, let's see. Cannot use case and array property add on a non-array. So that means that we've borked our logic here somewhere. Let's see. Oh, this is for something else. I actually want this. Let's close that. Let's do a search for this guy, and we'll put a breakpoint right there. Right? So what are we trying to do here? Okay, so we're trying to add an object to an array. That makes sense. Okay, so we're trying to add... Oh, do I have the properties backwards? Oh, what a dungus. Okay. I do. Why did I do that? Okay. Shader serializer C. 181. What a dingus. So this should be... Oops. Bindings array. And then the object that we're trying to add to it, right? There. I wonder if we've done that anywhere else. I'll bet the deserialization might have that same issue. Maybe not, though. Required field bindings not present in binding set 0. Cool. I assume that means we are deserializing now. Nope, we're still serializing. All right, let's see. Required field bindings not present. Okay, so I'm hoping we can just grab this. probably could have written unit tests for this, but sometimes it's just faster to do it this way. Okay, so this is going through our bindings. What are we trying to... So this is the bindings array. Binding set... Wait. Yeah, we are deserializing. Okay, I thought so. So this is saying it doesn't have bindings within a binding set. So what is the source that we are dealing with here? Shader config source. It's entirely possible that that is just wrong. Isn't there a way to... That is way too long for me to actually grab that. And this is one of the issues with this debugger that I don't really like, is there's not a quick way to, like, say, display the entire string when it's a really long string, right? Because it just kind of, like, truncates it and then says, well, if you don't have what you need, sorry about your luck, pal. Yeah, see, it just truncates it after a while. So my question is, can we tell from this? We can't tell from that. Let's see. What we can do, though, is grab the resource name. So kstring, kname get, rather. Whoops. Kname string get. And just paste the kname in there. So this is material standard. So for some reason, I'm guessing that means that our serialization failed because we're not getting the value that we expect back in. Let's see. Why not using GDB for debugging? I'm just not quick with it. It's on my list of things to get better with, but I'm just not fast with it. I mean, I am inadvertently using GDB under the hood of this thing, but yeah. It's one of those things. I use this also because it's a consistent debugging experience across Windows, Mac OS, and Linux. Whereas GDB, not so much, at least on Windows. And I refuse to use, like, full-blown Visual Studio. No, thank you. Bad Cop, how's it going? Good to see you. I'm just catching up on chat real fast. Looks like I'm quite behind, actually. You had to embrace... Wait. Where was that? You had to embrace VS because NeoVim LSP got me tight on Windows. I never really had a problem with it on Windows, so that's interesting. Spending too much time setting up an IDE when I challenge myself to create a game from scratch is not the most brilliant idea, at least not at the beginning of my journey. Yeah, I mean, that's fair enough, right? Like, I've gotten good enough with it now where I can be proficient in editing this way, but it wasn't always the case for me, for sure. You got to start sometime, right? Depends on what other things you're trying to learn at the same time, I guess. Fun fact, I ditched SDL3 to building my own Win32 platform layer. It's so much easier than learning SDL3, probably writing more code, but everything just makes more sense. Yeah, that's my experience as well. I mean... So my entire platform layer is 1,000 lines, 1,100 lines of code, almost 1,200 lines of code. And this includes everything from like file handling to memory management to file watchers to threads, mutexes, all that stuff. That's all in here. And windowing, of course, right? So, yeah, I found it much easier to just roll that layer myself too. That one, Linux was an option, but you decided to use DirectX 11. Fair enough. It is a little easier than Vulkan, I'll give you that. MSDN docs are easy to follow whenever I want to know something about the API I'm using. That's not always the case, though. I've run into many circumstances where MSDN documentation is just not great. But some of it is for like the stuff that's been around for forever. But
You dingus.
Thank you for the follow. Appreciate that. Using Windows is much more painful to me than anything else. Yeah, file rate speed on Windows is absolutely terrible compared to Linux. Which is why building on Linux is so much faster, incidentally, if you have a lot of files. Is Kohi suitable for making 2D games, or is it 3D only? So that's the cool thing about a 3D engine, is it can do either. And so I don't actually have a... I can't run it at the moment, but I can at least show you a screenshot. Let me pull this up. All right, so we have this sort of UI layer here that is literally a sort of a 2D renderer that powers this. So, while I'm using a 2D renderer here, which is really nothing but rendering in 3D only without a depth buffer, potentially, and just using an orthographic projection matrix, that's really the only difference, right? It's not a huge deal. So anytime you've got a 3D engine, going to 2D from 3D is not a huge deal. Going the other way is much more complicated. Hypnotic Games with a raid of 45. Thank you so much for the raid. How are you? What are you getting up to on stream, sir? Thank you so much for the raid. Welcome, raiders. It's decent timing, actually, because I was just catching up on chat. So welcome in. I'll give my opening spiel here in just a second. GDB and a TUI is kind of very good. Yeah, and that is one of the things I want to experiment with next in terms of debuggers. It's just unfortunately on Windows, it's not so much, right? Thank you for the follow. Good day, you good dunce. I love it. Yeah, well, welcome, readers. Like I said, I'm glad you guys are here. Need to make your game trailer? Awesome. Yeah, I can't wait till I get to that point, but I'm quite a ways off from that. All right, so I guess what I'll do real quick is just give you guys a quick rundown, all the raiders, as to what the heck it is we're doing here. So I'm going to drop a link in chat real fast. What we're doing on this channel is we're building something called the Kohi game engine. So it's a game engine written completely from scratch using C and using Vulkan as its initial rendering backend. I say initial rendering backend because we do have support for Direct3D as well as Metal in the future. So we've written things in a way where those things are decoupled and can be expanded in that manner. It is cross-platform, having said that, so it's available on Windows, Linux, and Mac OS. It is early days in development, so it's not quite production ready yet. We're still making, rather large sweeping changes at this point. But we are getting close, right? We've started making a game with it, and we're sort of using that as the test drive of the engine, if you will. And so basically what this is all about is it's a series on a way to build a game engine, and it is a way to build a game engine. It's not the only way to build one. It's not even necessarily always the right way to build one. We do lots of experimentation and trial and error on the channel and deep dives into why those things do or do not work. And then if we need to refactor, we go ahead and go through that. And one of the more important things that I try to do here is always explain the thought process behind this stuff. So that you guys have, a full documentation of what it takes to write a game engine from scratch, all the way from creating the Git repo to where we are now.
You dingus.
So with that said, this is sort of KohiEngine.com is sort of the hub for the whole project. So I've got links on here to GitHub, GitHub, also YouTube and Twitch. We do have a Discord server with about 1,000 people on it, and I've got a Patreon link here. I don't have any sort of sponsors or anything aside from you guys. So if we go into the GitHub repo itself, this is it here. The engine itself is Apache 2.0 licensed, which means it is free to use either for personal projects or commercially. Does not matter. All that I ask is that if you use it, you say you use it. And that's literally it. There will never be any sort of licensing fees or royalties of any kind. Nothing having to do with the engine will ever be paywalled at all. This will always be free and open source because it's an educational resource, and I believe that stuff should be free. The game that I'm making with it, which is a 3D action RPG, that will not be open sourced initially, but we will occasionally take bits and pieces that are relevant or that could be generalized, and we will port those over to the engine. And create sort of game application templates to go along with the engine as we go. So that is pretty much what we're doing overall. And at the moment now, we are actually debugging our way after a rather large refactor to add storage buffers to our shaders. And all of the changes that we had to make to support that, as well as we simplified and removed a lot of code having to do with shaders in general across the system. So that's kind of what we're doing at the moment. Let me go ahead and catch up on comments. Let's see. All right, so does Windows have any advantage besides just having more development and support there? That is the advantage, right? Is there's just more users, bigger user base, right? Anyone from the raid not following, it's worth it. I appreciate that. Thank you very much. I appreciate you saying that. That means a lot to me. Thanks, good week. Didn't notice the raid. Fair enough. Let's see, because light occlusion might work a bit differently in 2D. I feel like I might have missed a message on there. Let me see. Oh, how difficult is implementing 2D lighting in 3D Engine? To be honest, I would probably still do it in 3D. And just flatten everything with a ortho projection matrix. I have made 2D games with lighting before, using like additive blending and things like that, and that does work. But you don't get support for things like normal maps, for example, with that, right? So it can work quite differently. So what I usually do, if I have the choice, is I will actually render everything technically in 3D, but use a orthographic projection matrix to sort of flatten everything and make it look like it's 2D. Probably Visual Studio dev environment can be good and bad at the same time, but for starters, kind of does the job. Yeah, I mean, I no longer recommend that people start with Visual Studio, especially if they're going to do C or C++ development. I think you're much better off learning the toolchain without the IDE doing all of that work for you. You're much better learning how the tool chain works, and then use something like an IDE that sort of automates that for you. Visual Studio, especially these days, is pretty large and bloated and heavy, and there's lots of proprietary things about it, like the project configs and all that stuff that don't translate to other environments, and that's usually the reason I discourage it. If you want to follow an experienced developer who explains what he's doing in understandable terms, you should check out the YouTube channel, series Developing Kohi Engine. You'll be overwhelmed, but learn everything you need. I appreciate the kind words. Thank you very much. Yeah, we do. So this whole series actually started off as a tutorial series, but we kind of outgrew that format, right? So the first, I want to say around 100 episodes were in tutorial format. It might be a little less than that. I can't exactly remember now. It's been a while, right? Thank you for the follows, by the way. How many lines of code? Well, let's look, shall we? So let's just do terminal real quick.
You dingus.
All right, so there's two different things here in terms of lines of code, right? So there's the game project itself, or the application. And so that one is only at about 6,000, right? And some of that is build scripts and stuff, right? So there's not a whole lot in the game code. But if we switch to the actual engine and do this again, right? Right now we're sitting at about 71,000 lines of code. And so that's actually down from about, we were almost at 80K at one point. And so in this kind of last refactor session that we've had going for a little bit, I've been removing more code than I'm adding, because I'm trying to simplify things, eliminate overhead, and complexity out of the engine. So we've actually been adding, we've actually been removing a lot more code than we've been adding lately. But yeah, that's the lines of code. Dustin, my dudes, good to see you. Been programming various languages for maybe a decade. At work, I moved into embedded C software. Don't make games, but the teaching style in Kohi is extremely transferable. See, embedded that's something I've always kind of wanted to get into, to be completely honest. That interests me as well. To like do that as sort of a day job would be really cool. Yeah, it would be all about that. I could probably learn from you on that one for sure. Yeah, thank you again for all the kind words. I really appreciate that. You create fire and water detection system, control panels, and cables. That's pretty cool. Yeah, that's very cool stuff. That would be interesting to me, because you really have to optimize as much as possible at that level. Cool. Yes, this is Arch, by the way. I don't know if you guys can see where I'm mousing. Yeah, you can. I jokingly named my machine Arch-BTW, right? For the memes. Why do you have JavaScript? So, one of the things that we, I guess I don't really need to pull it up, but one of the things I've always kind of believed is use the right tool for the job. And there was the need that came up for an item editor, right? Because we actually have a custom item database that's built to be able to handle all of our items that we get in the world, right? So I needed something for that. I also needed something to handle localized strings. So it's called ItemDB, but it actually contains more than just items at this moment. And so that handles all of my localized strings, right? So I can add strings for different languages in there, and then reference them by code and have them show up. And so I basically created a database, and I needed a editor for that database. But it didn't really make sense. Like, I don't have all of the UI controls that I would have needed to actually make that editor in the actual engine. So what was really easy for me to set up was just a simple web page that essentially gave me a huge form that I could fill out depending on the type of thing that I'm trying to create or edit. And then I could export that to a binary blob and then read it into the engine. And so we have some JavaScript there for that because it just was very quick to prototype, and it's not going to be a tool that I'm shipping with the game. So I don't mind using something like that for a tool, right? I think that is perfectly acceptable. Holy crap, another raid. Kuju raiding with a party of 32. Thank you so much for the raid. Welcome, raiders. Kuju, what did you get up to on stream? I think I saw, I popped in for a little bit earlier. I think I saw you were doing some networking stuff. Did you get past that? Yeah, thank you so much for the raid. Welcome, raiders. So for those of you who aren't aware, I'm just going to give the introduction again. So sorry, bear with me here for a minute. So for those of you who are new to the channel or haven't been here before, we are making something called the Kohi game engine, which is a game engine written completely from scratch in C using Vulkan as its rendering backend. Initial rendering backend, I should say. We do have support for Direct 3D and Metal planned for the future. And so the engine has been designed with that in mind. It is cross-platform. It runs on Windows, Linux, and Mac OS. Although it is still pretty early days, I do not suggest trying to use this in its current form for anything production. I am creating a game with it right now. It's a 3D action RPG. And I'm sort of using that to test drive the engine and eliminate pain points as I find them. One of those things I'm actually doing now. We've recently just performed a rather large refactor on the way that our shaders work to simplify and eliminate a lot of overhead with that. And so, yeah, the engine itself, and I'll just drop this link in chat again. The engine itself is free and open source. It's Apache 2.0 license, which basically says if you use the engine, all that I ask is that you say that you used it. And it doesn't matter whether you're going to use it for a personal project or a commercial project. That's all I ask, right? And so the engine itself, we've got a basic PBR pipeline with cascading shadow maps, nothing too fancy, right? We've got a UI layer with custom UI controls and stuff like that. Again, all written from scratch. UTF-8 text rendering. Although we don't support everything, we do support a wide variety of glyphs. And so, yeah, that's kind of the project. And then we're building a 3D action RPG on top of that. So, yeah, again, thank you so much for the raid. And I do see your guys' messages over there on the YouTube side. I'll catch up to that side in just a second. Let's see. Was working on my library from game networking sockets to reliable plus netcode. Wait, to reliable net plus netcode. Low reliable. Gotcha. Got to dip really fast today, though. Have a good rest of your stream. Well, I appreciate it. Go get some rest and whatnot after stream. I totally understand that. Thank you again for the raid. Aid, I would say no. This is kind of inspired by what he was doing. In fact, I even put that on here, but you know, this is different than what he was doing. So we were actually what we're doing on here is we're actually building a reusable game engine. All right. Let's see. Okay, I think I've mostly caught up on chat on the Twitch side. All right, so let me catch up on the YouTube side. Let's see, MTK, music, hello. Let's see. Using SDL3 for now. When I'm happy with the state of what I'm building, alpha state, I will switch to native API. Don't want to struggle with in everything I do for now. Yeah, that's fair enough. What do you use for audio? So our audio is a plugin, much like the renderer is, right? So we have so we essentially have in here a plugin system, and the renderer is a plugin, and the audio system is a plugin, right? And so we have this front end and a back end. The front end is what the rest of the engine interfaces with, and that's true for the visual render as well as the audio system. And then we have a back end, which is where all of the render API specific code exists, like for Vulkan. And then for the audio, we have an OpenAL plugin. So this means that we can also use other audio backends. So like Fmod, for example, will be another plugin that we'll use or make eventually that'll go with this. What is the best TUI library that could be used to create TUIs? Good question. I don't know. I haven't done a lot of that. Let's see. Where can I find this scene with the blue-green flags? Okay, so you're talking about the Sponza scene. Where did I put that? This guy. You're talking about this. That's Sponza. I'll put it into the chat. You'll have to Google for it, right? But there are versions of it out there that you can get in like different formats and stuff. Any release. So we do have releases, right? But they're not production ready yet. We're working on 0.11 right now, just to give you an idea. New to the stream, what's going on? So we got raided a couple of times, so it took me a minute to catch up from that. But we are currently debugging after a refactor effort for our shaders. What's the compiler you use at the moment, MSVC? So I use Clang because it's easy and relatively the same to set up cross-platform. So I use Clang, which is really just a front end for MSVC, kind of on Windows. But yeah, that's what I use right now is Clang, because it's consistent. It's relatively consistent across platform to set up. Day job is embedded to work with people and objects with mmWave, 60 gigahertz radio waves. My dyslexia kicked in hard there for a second. Vital signs pose detection. Okay, that's pretty cool. So medical equipment, in other words. Yeah, that's pretty cool. Thanks for reading both YouTube and Twitch chats. I try. Sometimes I can keep up with it, sometimes I can't. Sometimes I have to skip messages, but... let's see. What do you work on your day job? So right now, I'm working on something completely unrelated. I work at Oracle right now as a developer. So it's healthcare software. So it's completely unrelated to this, but pays the bills, right? Let's see. Okay. All right. So, where were we? I don't even remember where we were. Let me rebuild, because I don't even remember if I... Oh, right. We weren't serializing bindings. Okay. So in our serializer...
You dingus.
We need to find out why we're not writing our bindings, right? So that was the issue. We're not apparently writing that out because we're not reading it back in, which is a problem. Attributes, binding sets, here we go. Binding sets array. So I think that means that we must have read in our binding sets. There it is, right there. Oh, yeah. We're adding bindings to the array, but we didn't actually set it up. That's pretty awesome. So let's take a look at... We basically didn't do this, right? So we created this bindings array. Add bindings array to the binding set object. Wait, that seems wrong. That is wrong. Yeah, no wonder. Okay. I did this kind of backwards. So this should be case and array object. No, case and object value add array. The object is going to be the binding set object. The name is going to be bindings. And to that, we are going to add bindings array. So for reference, what casein is it's actually a custom language that we wrote. So if we take a look at take a look at this file, it looks a lot like JSON, but it's not exactly the same. So this was one of those things where we just kind of did a little bit of exploration on what it takes to kind of create a custom storage format that we can use for a whole bunch of things. And so it supports, all of your basic types, your numbers, your strings, your arrays, your objects. And we even have extended types that we can support as well, and parse those directly out. I don't think we actually have any samples in here. Let me open one of these material files, because this is probably a better example of some of the things we have. Or actually, I'll open up a zone file. So this language supports things like this, where we can say we have in between these quotes here, we have a vector 4, right? And so that is stored as a string as far as the casein is concerned, but we can then take that string and convert it to a vector 4. And we can both serialize and deserialize that. And so that's an advantage to kind of having our own thing here is we can also build in the functionality to just handle our custom types like that. Transforms is another one, right? So let me move this over a little bit. So, a transform, we have a bunch of numbers here. We have position, so X, Y, Z. And then we have rotation, so X, Y, Z, W, right? And then we have scale. Now this scale, obviously that's a 0 scale, but it doesn't matter because it's really only a point in space that we care about here. But yeah, that's kind of what we're troubleshooting now is we changed up the format of our shader configuration files. And so we've also got some of those things that are generated in code. And so we basically have to serialize that and deserialize it to make sure that it runs through the same process as your normal shader would. Let's see. Just catching up on comments real quick. Okay. Beat me to the auto mod. Yeah. I just happened to look over there, Spiro, and see it. Yeah, that one was fine. It catches weird things sometimes. Sometimes I don't let stuff through, but sometimes I do. Let's see. I have a question for you. If I wanted to get started in graphics programming for VR AR, what do you suggest, OpenGL or VK? Ask a few people, and they said start with VK. If you struggle, you will learn higher quality, higher quality, low level instead of GL-ism or some bad practices. Okay, so my feeling on that is a little bit different, right? If you don't have any experience with graphics programming, what I normally tell people is start off with OpenGL because it's a much simpler API. There's less friction at that level. Learn the graphics programming concepts. That way you're not trying to learn that and also learn all the stuff that is kind of goes with Vulkan, right? Because Vulkan is fairly complicated. So I usually say to people, learn OpenGL first to learn the graphics concepts. Don't pay as much attention to the OpenGL API and the way of doing things as much, right? You're more doing that to learn concepts and how to actually build a renderer, right? And then as soon as you've built like a couple of simple renderers, dump OpenGL and move on to Vulkan. Because OpenGL is deprecated at this point. It's not going to get any more updates. It's not going to be obsolete anytime soon, right? I think if anything, if it hasn't started happening already, I think what you're going to see is GPU manufacturers and their drivers are basically going to just take OpenGL calls and translate them to Vulkan under the hood anyway. And they may already be doing that, right? But yeah, ultimately you're going to want to use OpenGL to sort of get familiar with the concepts, but then dump it and go to Vulkan. Because if you start off with Vulkan and you're trying to learn all of the graphics programming concepts at the same time, more than likely you're going to be overwhelmed, like a lot. So that's that. Let's see. Rotation X, Y, Z, W means you use quaternion, and any particular reason you went with that, as opposed to what? I don't want to use Euler angles if that's what you mean. Gimbal lock. It's a big one, right? All rotations in the engine are represented by quaternions except cameras for now. But that's probably going to change too. At some point, I'm probably going to convert that to quaternions as well. Yeah. Now, when it comes to an editor, I might like translate the quaternions to Euler angles just for the editor UI to make it a little easier to understand from that perspective. But in terms of how it's actually represented, you always want to use quaternions for rotations in a game engine at this level. Let's see. So hardware manufacturers can kill OpenGL anytime then? No. Well, okay, they could, right? But they'd piss a lot of people off, right? Because you've got 30 years of... No, actually it's... about 30 years of legacy, right? A little over that, actually. And so by them saying, we're not going to support OpenGL at all anymore, they'd basically be breaking 30 plus years of software. You can't do that, right? None of the GPU manufacturers are going to do that. They don't want the backlash from that, because that would break a lot of stuff, and not just in the gaming industry, but on other devices too. Like medical devices that use imaging and stuff like that. There's a lot of stuff out there that outside of gaming that uses that. So they're not going to do that. Yeah. Like I said, if anything, they'll just take those calls and essentially pipe them through to Vulkan or DirectX or whatever, under the hood. I think that happens on some level on Windows anyways right now. Okay. Let's see. What do you think about mathematics and graphics? How much would I need at college level, PhD level, or basic linear algebra, calculus probably? Yeah, so linear algebra, some calculus, and trig are what you're going to need there. You don't need PhD level. I don't have PhD level. And to be completely honest, like, once you understand, your basic vector math, there are certain concepts that you don't necessarily have to commit to memory. You can kind of just look them up. Like, I look stuff up all the time. I've fumbled about with it a lot because we wrote our own math library from scratch in this engine. And, I had struggles there for sure because I don't have all that stuff memorized. It's kind of a program it once and then forget it kind of thing, right? As long as you understand what it's supposed to do. The implementation details don't matter once you actually get it working. All right. All right, so let's see. Let me build this real quick because I don't know that I did. And let's go back to our debugger and relaunch and see if that fixes that issue at least. Okay, it looks like it did. Okay. Offset is ignored for types other than UBO. So my question would be, why are we getting that warning? Oops. Hitting the wrong dingus key. Why are we getting that warning? And I'm actually going to kill some of these other breakpoints. Get rid of some of these other ones. All right, so let's see exactly what this is doing. Okay, so offset. So if we don't, I think that should be a positive check, not a negative. So let's see, that's going to be, let me bat this out of the way here. Okay, so this is optional. So only if we do have it, do we actually do this check? Yeah. That's just inverted from what it should be. Okay. So let's go ahead and, whoops. Let's go ahead and move this back. All right. Well, we still got that. So what is the type then? SSBO. Do we have... let's see what... We don't have a name for the asset. Perfect. Okay, I suppose we might be able to actually look at the name for the binding set. So let's see, where is that? Here we go. Binding set name. Let's grab that. Material, okay, so we're in the material standard shader global binding set. Okay, and the issue that we're running into is on the SSBO, we have an offset. I'll bet this is always serializing it, even if it doesn't really need to, I think is what's happening. So let's take this and go to serialize. Yep, we are. What do you think? Did we actually have... I think for UBO or SSBOs, we don't actually need the offset. So let's comment that out. And bring this. I gotta go. Do you stream at, when do you stream usually? Every day? No, I don't. Yeah, it's Wednesday and Thursday. Yep. So yeah, but yeah, thanks for stopping in. Appreciate that. Yeah, we start at, usually start at 9 p.m. Eastern, but sometimes I'll start a little bit earlier than that. Like tonight I started at 8:30. So have a good one. Let's see. What do you think about mathematics and graphics? Oh wait, I already answered that question. I'll go now and draw some triangles. Thank you so much. Awesome. Yeah. Draw some triangles. Let me know how that works out for you. Keep me posted. I do like hearing about that stuff. Okay. Let me relaunch this. Okay. So here we go. All right. Now we're getting a crash here, which means that we're probably passing something stupid here. So let's have a look at what we're passing here. We're not passing the string, is what it is. So that is, oh, that's actually in the Vulkan backend. That's interesting. Okay, so 2266. So this first parameter is supposed to be the function name so that we can actually see where the heck it is. Details, right? All right. So now we can actually see some errors, right? All right. So loading assets. All right. Render buffer named storage buffer lighting global not found. Okay. I think I know why that is actually. So this is kind of some of the errors that I was figuring I was going to run into. Also, yeah, lighting global is not found. I think that's because the lighting system just isn't being initialized like it should be. So if we take a look at the light system itself, that is indeed creating the SSBO, right? So Kohi storage buffer lighting global. That is the same as what we're seeing right here, right? So at least we have the name right. But I'm guessing that means light system initialize is probably not being called anywhere. So, oh, it is. So my question would be, why is that not found then? Unless we're not registering it correctly when we do create it. So we do go through here and all right, you know what? Let's actually not. Let's just go to, let's go to here. Oh, you know what? I think I know what it might be. I'll bet we're not even, yep. Whatever is trying to use this is being stood up before the lighting system. That's why. Okay, so that means, let's go to engine. All right, so here's the lighting system. That means that we've probably got something in here. Yep, the material system has a direct reference to that, right? So this actually has to go before the material system. And we might have, that's going to work for that one. Where's the transform system is also going to be needed. Actually, that one might be all right. Let me see. Yeah, that one's fine. That's created early enough. That one's fine. I suspect the animation system one is going to be a problem, because we don't actually have that being created yet. So that is going to be an error we're going to have to fix without actually creating the animation system yet, because we're not there yet. Okay, so that is being called now, so that's good. Let's continue. Okay. Here we go. So we've created the lighting global storage buffer. We've created the material one. Animations global. That's what I figured, okay? So we'll have to tackle that as well. So the animation system, did we actually even, I don't even know that we've actually set that up. Let me see. I'm going to take this really quickly. And yeah, we've not done anything in the animation system yet. I think the only reason I created these was so that I actually had the name available. So actually, let me do this. All right, I'm just going to use this as sort of my template. And let me take this over to animation system H. Actually, I want this below here. And we'll go ahead and, well, actually, we don't need to export that one. That's fine. All right, and then light system state, this is going to be, I guess we'll do here. Let's type def struct animation system state. Right, and we're just going to do U32 dummy for now. Right, that way we can do animation system initialize, animation system states, and then we've got to initialize, so obviously we need a shutdown, return type void, and we'll do shutdown, and we don't need that, and all we need is the states. Let's actually also do something really quickly. Let's do type def struct animation system config. Right, and again, U32 dummy. Right, that way we don't have to use a void pointer here. We can use animation system config. And we'll actually, actually set that up as a const, right? So we can take both of these and go to the C file, paste these in here, and we'll move this one here, delete that, take this down here, and then do include animation system H. Okay. And then we want animation system state, and oh right, we need the buffer in here, right? So we need instead of this we can do k render buffer, and we'll do global animation SSBO, right? And now we can say global animation SSBO, same thing there. Include the lighting, or the renderer front end rather. Like global SSBO data. We don't have that structure either. So this is going to be a structure that we're going to use to determine the size of the SSBO, right? So that's just going to be a animation SSBO data, right? So I'm also going to go here, and we're going to scaffold this. And again, we'll come back and do this stuff later. Type def struct animation global SSBO data, and then we'll just do something stupid here like I don't know, U32 stuff, right? 100, right? Just to make it, or maybe I guess we'll do a bunch of mat4s, right? Whatever. Just to make it kind of take some decent amount of space. Engine systems gets, we need that, and then this is going to be render buffer name animations global, so that we've got that. All of that should be fine. All right, we've got all of that, and then we also need animation system state, right? And for the shutdown, we'll do if states, and then we'll do render buffer destroy, and that's going to be engine systems get renderer system, and the render buffer is going to be state SSBO, right? Just so that we don't get Vulkan errors on shutdown. And then we can go to engine C, and right after light system, we can put the animation system, which needs to be before the material system, right? Material system and its renderer, rather, which is fine, because this is just going to handle animation data. So we need to go here, add some memory here for this. So we're going to say animation system requirements, animation system, right? So we'll do Oops. Swap out all of these. All right. One more. Systems, animation. What am I missing here? Oh, did I forget to change animation system state? Oh, whoops. There we go. Oh, we don't have that included. Dingus. Okay. So there's that. And let's just change this also to animation. All right. That should solve that issue if I've done it correctly. One more thing in the engine also. Let's see. Light system is created before material system, so we need to go to let's see. Light system is shut down here. That needs to change to after material system. And actually, K material renderer shut down. We didn't do that either. All right, so we need that one. But then also after, or I guess before this one, system shutdown. And that's going to be systems animation system. All right, I think I've gotten everything. Let's at least see. Does it build first off? Yep. Let's see if it resolves that error at least. I know there's going to be more. Is it stuck in a loop somewhere? Oh, that's interesting. Free list allocate block. Why is it getting stuck there? Shader creates. Sampler count 1. Max instance counts. Did I do something stupid with this loop? 181. I must have. Or maybe it's outer loop. Binding set count is 2. Okay. I think this is probably where I'm going to leave it for tonight, to be completely honest. Oh, interesting. What's the shader it's trying to do right now? Let me just look at that real quick, and that'll give me a good place to leave off. Material standard. Okay, so I think there's something still going on with that. But let me look through here real fast. Global lighting storage buffer. Created animation global storage buffer. Perfect. Okay. So all of our storage buffers that we need are being created now. Except for the one for the material system. I don't see that one being created. But that might be because maybe that happens after the shader creation, which is what it's hanging up on. So, all right, we'll come back to that. Let me catch up on a couple things on chat. And Fonzie, first time chatter, finally caught a stream. Welcome. Unfortunately, we're getting ready to end, but yeah, welcome. Glad to have you here. Magette's good to see you. Mostly lurking. That's okay. Remembering how I used to build things in C after 3 years is really giving me trouble. Fair enough. Where does the hate on globals come from? Even in Quake Engine, you can see. I assume you mean they're very directly using globals. All those globals being used in different files. Guilty of having a common H header. So that's another one of those clean coding things that doesn't necessarily always make sense, right? Especially for something like a game where you have like global state, like it can be fine, right? The common like OOP way of doing it is they say, oh, you should avoid globals, just create a singleton instead and wrap everything in a class. That's dumb, right? Why bother with that, right? Usually I will wrap any globals that I do have in like a struct just to kind of package it up and then maybe pass that around. I don't usually like to set things as static anymore. I used to do that a lot, even in this project in its early days. I used to, do that a lot. But the problem with that is if you want to hot reload any of your libraries, that instantly breaks things. So I try not to do that anymore. I've still got some spots I need to remove that. But yeah, I don't necessarily have hate for global variables. They have their use. Just like goto, right? A lot of people say, oh, don't use goto. It's terrible. No, it actually has its use, right? Just use the right tool for the right job. Global overuse is something that can be easily abused. Yeah, I mean, that is a thing, right? But like people saying never use globals, straight up they're wrong. Put it that way. It also gets a little bit weird and again, like static data, it gets weird in multi-threaded scenarios. So you have to watch that, but TJL, how's it going? Good to see you. First time chatter, welcome. I like the thread local concept and modern-ish C++. Fair enough. I think it's about threaded apps. Yeah, if you're talking multi-threading, then that's a completely different discussion, for sure. Most people hating on things in programming are very dogmatic, don't pay too much attention to them. Show them a go-to and let them boil their rage. Yeah, I mean, let me do this real quick. I've used the go-to 175 times. So, yeah. Take that for what you will. All right. Why do you have a direct reference to light system and material? I thought, at least inside my head, it's the renderer's responsibility to pass in the light stuff to the shaders, not even to materials. That's kind of where I put it for now. I'm not convinced of it either completely, but the reason it's there is because I need to be able to bind that when I'm referencing lighting data. But in the long term, it's probably not going to be there. It's in the material renderer, which is more sort of a manager of like the material specific shaders. And those do interact with lights. So there's a storage buffer for lighting that is used by the material shaders themselves. So that's kind of why that's there for now, but it doesn't necessarily have to be. I'm probably going to remove it at some point, but for now it was just for debugging purposes. It was kind of easier just to put it all in one spot, and then once we have it working, we'll clean it up. All right. Thanks for the stream. Gotta go. Yeah, I gotta go too, actually. I have work early in the morning. Let me find somebody to raid. I want to say thank you to all of you guys who were here tonight. Thank you guys for hanging out and following along. It was a very interactive stream, so I really appreciate that. And of course, the raids were awesome. Okay. So let me see if I can find somebody that's kind of doing something semi-related. Oh, you know what? We are going to raid Sergeant Pepper, because he is almost never online when I'm actually looking to raid somebody. So we are going to raid him. Looks like he's doing some Godot development, and he's using Rust, which is curse word on this channel, but not on his channel. So we'll go ahead and see what he's up to. He's a good buddy of mine. He hangs out my stream all the time. So we'll see what he's up to. And yeah, thank you guys for being here. If you haven't already, I would greatly appreciate a follow on the Twitch and or YouTube side, or both if you're so inclined. Just trying to grow the channel and whatnot. But yeah, anyways, I will see you guys. Thank you for the follow, by the way. I will see you guys on the next stream. See ya.